Good day. Today, we will be talking about methods of indirect measurements. Today, we will teach you how to estimate the width of a river or an obstacle you can't cross, and to estimate the height of a tall object. Also, note that these methods of indirect measurements are only estimates, they're not the actual number.
So for this method, you're going to need one hat. Step 1. Stand on the edge of an obstacle you can't cross. Step 2. Adjust the position of your head so that the very edge of the opposite bank is aligned to the very edge of your visor. Step 3. Without changing the position of your head, turn away from the obstacle until you face dry land, which you could walk unobstructed. Step 4. Try to visually mark the farthest spot you could see, the last thing or spot that the device doesn't cover.
This method is applicable to congruent triangles by using the ASA property, because when we move the visor to aim to the area where we can't cross, we are able to tell the distance from the area by turning to an area that we can cross. Since it is the same distance, we can say that one side of each triangle is equal. Also, since we turn in a 90-degree angle, which is opposite to that of the object, we can derive that they share a common angle through perpendicular angles. Another angle that we can use is the one that is made from the tip of the visor to our eye level, as seen from the picture and from the tip of the person's eye. Through these two common angles and one equal side, we can recognize that they are congruent through the ASA property.
Good day. I am Nancy of IQ. Today, I am going to estimate the height of a tall object. In order to measure the tall object, you must need a mirror. First, we need to mark the base of the tall object and we name it point A. We need to place the mirror in a certain distance and mark it AB. Third, from point AB, we need to walk backwards until we see the tip of the tall object in the mirror. Then, from this point on, if you see the tip of the tall object from the mirror, you mark that spot point C. Then, you measure the distance from the mirror by using pace factor. Then, by measuring the distance of point AB from point A, we also use pace factor.
She wants to pressure what is that in silent.
Furthermore, always remember not to slouch when looking at the mirror.
Now that Lance has finished demonstrating the method of estimating the height of a tall object using a mirror, the biggest question now is, how then do we compute for the height of this tall object? In order to do this, let us review the measurements that we have gathered. But before we review our measurements, let us take into consideration of some things. That one pace equals 2 steps. That point A is the base of the tall object that we are trying to measure. Point AB is the location wherein the mirror is placed. And point C is a spot wherein Lance can see the top of the tall object in the mirror. Now back to reviewing our measurements. Lance has a pace factor of 1.37. Lance took only one step from point C to point AB, which is equivalent to 0.5 pace. Lance took 6 steps from point AB to point A, which is equivalent to 3 paces. Lance's estimated height of eye level is around 54 feet, which is around 1.63 meters. Now let us find the distance of point C to point AB and from point AB to point A. The formula that we are going to use is distance equals space factor times number of paces. Using this formula, we are able to get the distance, which is 0.69 meters and 4.11 meters respectively. Now, let us sketch our figure and plot our measurements so that we will be able to understand it better. As one analyzes the figure, we can actually see triangles, similar triangles in specific, through the AA property. As Lance said a while ago, in order that this method would work, one must not slouch but instead stand straight. This means that the legs of the person is perpendicular to the ground. As we all know, perpendicular lines are two lines which meet at a right angle. Through this, we can see a right angle. Furthermore, the tall object is perpendicular to the ground also, which means that there is another right angle present. Therefore, we can see two equal angles in the two similar triangles. Moreover, light passes in a straight line. Here is a figure which shows the reflection of the mirror. In here, we can see vertically opposite angles. Angle A is equal to angle B, angle C equals to angle D, and angle E is equal to angle F. And there we have it, two equal angles which completes our AA theorem, which proves that these two are similar triangles. Now that we know that they are two similar triangles, let us now finish solving the height of our tall object. By using proportion, we can see that the length of AB to A, which is 4.11 meters, over the length of C to AB, which is 0.69 meters, equals the height of the object that we are looking for over the height of eye level of Lance, which is 1.63 meters. By multiplying both sides with 0.69 and 1.62, we can get the estimated height of the tall object, which is 9.71 meters.